Hello there. Hi there, YouTube. My name is Jay Chatiti.
And I'm Alex Houghton.
We're both graduate students here at CU Boulder, and we're going to run tonight's open house night to show you some awesome astronomy here at SBO, Sommers-Bausch Observatory.
As you can see by the fact that we are full color, that shoulder over there, there it is. And that is the sky right now. This is not through the telescope, this is just through the camera, but it's still awfully bright, which, as you will know from your own life experience, makes it very difficult to see the stars, even with a fancy telescope. Oh, I chose the right shoulder, like that one there. So at the beginning here, we may be, we're improvising a little bit until the telescopes can get going, but I'm happy to talk about the telescopes and why we can't see the stars during the day, because that is not as much of a given as you might think. If you're on a different planet, you would potentially be able to see the stars during the day, depending on the makeup of the atmosphere. So basically what happens is when the sunlight, the reason why we can't look through the space through there right now is because the sun, which is back behind me, it's the other way, light from it is still being bent around through Earth's atmosphere, is hitting a nitrogen molecule, and then bouncing off and coming back to my eyeball and to the camera there. And that's known as Rayleigh scattering. And that's why the sky is blue. And so we need to make the sun go farther behind the Earth so the light doesn't bend around and bounce off of that. And then we'll be able to look through the atmosphere and see the stars and nebula and planets, all of which we should be able to take pictures of tonight.
Alex, why does the sun... actually, let me rephrase the question. What is really happening when there's a sunset, when we look towards the sun?
Oh, so generally, when you look through the sun during the day, you're looking through a very small portion of the atmosphere, right? Sun is like here, your Earth here, and then you look up, and you see the sun. And so some of the sun has to come through the atmosphere, which is good. There's a little less atmosphere here in Colorado, so more of the sun makes it through the atmosphere, including high energy particles from the sun, known as UV light, and they will give you a nice toasty sunburn, which I have realized, it's not the first time, but I realized that I am taught the lesson repeatedly by the sun here in Colorado. We have a mile less of atmosphere to look through, and that does make a difference with regards to UV light. Now, at sunset, there's a big whole chunk of atmosphere to look through, because the sun is now over here, and you're standing here on the edge, and the sun has to go through a whole slice of atmosphere to get to your eyeball. And so more of the light is bounced away and goes off in other directions, as we were talking about before. However, red wavelengths of light can travel through that much more easily. And so the sun tends to look red or orange during sunset.
Sweet. Do you want to give them a tour of the observatory?
Sure. Do you have the ability to do that?
Yeah, I think so. Let's switch cameras to my laptop.
We're going to camera 2. Oh, it's still streamed. There we go. I'm live on YouTube. All right, great. Hello. So while we're waiting for it to get darker, and it is getting progressively darker, we'll be able to take some pictures before the night is up here. We're going to give you a tour. We're going to start with the deck here. So generally, you are when we're looking at you, we are seated here. There's Jay. And you can see that there's 2 computers there and 2 screens that show what's going on those computers. And those are the command station. That's the workplace where the job gets done. And so you can kind of see on the screen behind me here, it's hard to tell, but that is a map of the sky. And that is reflective of the software we use to drive the telescope, known as Skyx. And that allows us to point at things in the sky so we can take pretty pictures of them. You want to talk about the telescopes here, Jay?
Sure. Hello again. So this is our Eastern telescope, Artemis. And over here we have Apollo, our Western telescope. They're both 20-inch telescopes. 20 inches refers to the diameter of the mirror. And I'm going to hold you up so you can see the mirror inside.
Ooh. Ah.
It's great to take a selfie if you're ever here in person. So hold out for when we're all safe and vaccinated.
Mm-hmm. Next year, things are supposed to be back to normal, so we should be able to do these in person again, which will be very exciting. All right, I'm going to talk a little bit more about the telescopes, and then Jay's going to show you the big telescope because he's worked with it, because those aren't the only telescopes we have here, though these two will be the ones that we're using this evening. So here on the back of the telescope, you can see that there's a whole lot of stuff going on, but the important part is in here. This is where the camera is, and the camera we want to keep cold because when it's hot, it will generate more fuzz and noise in all the pictures we take, and we're trying to reduce noise at all times when it comes to our photos. You can put an eyepiece on the telescope here where this duct tape is. There's no eyepiece on the telescopes right now because your eyes are a mucous membrane, therefore a vector for coronavirus. You didn't know you're going to get biology tonight, but you are. All right. We also have the ability, of course, to move and point the telescopes and focus them, and we will be doing more with that later. But before then, it's starting to get a little darker. Soon. I'd say 5, maybe 10 minutes, and we'll be able to start taking some pictures. Jay's going to show you the other telescope that we have here at SBO.
Sweet. So we're going to take a little journey inside our least favorite place since the pandemic started. I'm going to go upstairs. We have a dome for a 24-inch telescope. Now, that sounds like it's not that much bigger, I know, but it actually is a big difference in terms of what we can do with that telescope. We can do something called spectroscopy. Spectroscopy is unlike taking a picture. Taking a picture, we get an image of the sky. Ooh, in the dark. And turn the lights on. There's it's almost like a camera room from the old. Sweet. Illuminated. Of a telescope. That is the 24-inch telescope here at Sommers-Bausch Observatory. And it might seem similar in design to the other one. To split light through a prism. Actually, it's not through a prism, we use something called a grating, but it's a good analogy. You might have used prisms you might have seen on the Pink Floyd album to see the dispersed light. And so basically what a grating or a prism does is it splits light into its component wavelengths. So we see colors like red, green, blue. Those are all different wavelengths of light. And so what our fancy telescopes do is they split all that light so we can examine the astronomical objects based on all their individual component colors. So we have an instrument called a spectrograph equipped on this telescope for students in astronomy class that I'm actually teaching for. This room is much more, has a much more powerful presence, I think. We'll be able to show you in person when we're all here. Anyways, yeah. This thing has a much more separated control room, unlike the other observatory. Unlike the deck telescopes, we have an actual proper room here where we use to control that big telescope. It's much more finicky though, and it's not as well equipped to see things by your eye as our deck telescopes are. All right, I'm gonna turn off the lights in here, and we're gonna go head back outside to the deck. I'd make elevator music for you if I could sing. Oh, I can whistle. Oh, I don't want to go that either. All right, go. And we're back. Ooh, okay. Should we switch back? You?
You can. I can share my screen.
Sweet. We're going to go to Alex now.
Hello. Maybe people can hear me. Hopefully they can. Let me share my screen.
4 people watching right now.
All right.
Us.
That's great. Here we have a very fuzzy picture of Sirius. Now, you may be wondering, I'm not sure if anyone can hear me. It looks like I'm talking. Okay, well, we'll try it.
I can hear you.
All right. You may be wondering, how can you take a picture? It's starting to get dark, but it's not dark yet. Well, here's the thing. Our telescopes are better than our eyeballs. So even though it's still light out, we have a couple tricks up our sleeve that allow us to take pictures of bright objects. And Sirius just so happens to be the brightest object in the sky from Earth. It is about to go down over the horizon, so we'll have to switch to something else soon. However, that's all right, because it's also getting darker, and the benefits of it getting darker far outweigh the detriments of losing Sirius as a target here. But you may be thinking, what are these donuts on your screen? If this fuzziness is the fact that you're pointing at something bright through a large, what we would consider to be a very large sky background, because it's very light out. What's up with the donuts? These we typically only get in long exposures because we're usually filming at night. But what happens with these is there's dust on the mirrors. And when light comes in and hits those dust particles, it scatters and creates a pattern. So you have a bright spot in the middle of the dust mote and a ring around it of negative interference. And you can see there's quite a few dust motes on this one. There's a way that we can adjust for this, which is called taking flats. But since we won't be taking too long of exposures and we don't have too long to spend with you this evening, we will not be taking new flats this evening. But this is Sirius, and this is a star. It is a blue star. It's pretty close by, and blue stars are very bright. So that allows us to take a picture of it, even when I can't see. Oh, I can see it with my eye just now. So it is in the sky and able to be seen. If you are in Boulder right now, it is over the Flatirons in the western sky, southwestern sky, I believe. So let's see, should I focus the telescope, or are we just going to roll and assume they're close to focused?
It looks pretty good. We can show them what the diffraction grading
Yeah.
is.
Since it's still pretty light out, I will try to focus on Sirius before it goes to bed. Oh.
Should I stop?
No, we need to turn the camera on for this so they can see I'll stop sharing my screen. So they can see the diffraction grading, because it's cool. All right, I'll go back over here. Okay, so these are our diffraction grains, and what they do for us is their light is going to come in when it comes from a point source like a star. These slits will again cause that light to bend in a pattern that's going to cause a set of lines over Sirius, which you will see shortly after I put this on and take new photos.
So focusing the telescope is really important for several reasons. When we're doing actual science, we want to get the most pristine images that we, if we're doing something like image science. Sometimes, though, we want to defocus the telescope for something, for a really prominent activity that we do now as astronomers called exoplanet follow-up. And I can tell you a little bit more about that. Alex is ready to start sharing his screen.
You can talk. I'm sharing my screen, but why don't you narrate what
Sure.
I'm doing as I focus the telescope? It
So-
does need focusing.
Here is the wonderful image with the diffraction spikes on the left. Here's how we know that the telescope is out of focus. This is the magic of the Bahtinov mask. It's that flat piece of plastic that Alex just put on the telescope. As those 3 diffraction lines you see that are coming out from the main star, from the star that we're looking at, Sirius, we want all of them to be aligned over the same point. And if you're looking closely, you can see they're actually not all aligned over the same point.
All right, I'm going to start correcting them now.
And now Alex is starting to change the focus so that we can see if we can get it in focus.
Hello, Daniel.
Hello.
Are you joining us? A surprise cameo?
Are you doing?
Open house night. Oh, we're doing both, sort of. We're using that one right now.
Okay. Wait. Well, they're seeing this.
They are seeing the diffraction pattern right here.
It
See
should be hearing J
Yep.
and seeing the diffraction pattern. And I believe they are. Does that look about right? A little farther?
That looks probably
It's pretty close.
pretty good for what we need.
All right. The telescope has been focused.
Nice.
Huzzah.
All right. Wicked.
Daniel, introduce yourself.
Hello. I'm another APS student here at CU Boulder. You've seen me in other transmissions before. And I'm here just checking that everything's working out. So, okay, here just checking the thing.
Yep.
Here,
We're live.
you're live on that camera and you're getting that monitor.
Nope, we're getting that monitor.
Yeah. What the heck?
Actually, we're not streaming
See if I
right
can
now.
get Mars.
Is this live on YouTube though?
Yeah, we're live.
You're streaming.
Yes.
See?
So you're superposing
There you are.
the camera, but they're never gonna see that. Oh, I guess they can see that.
Yeah, we're not screen sharing right now. It
Right
works.
now they are looking at YouTube.
Sweet.
Yeah, you have to screen share though. No, they were seeing that before.
Yeah, they were seeing that
Yes,
before.
I
We
was
stopped
screen
sharing.
sharing at that point in time.
I have no idea how you guys are doing this.
We're we're
We're
multiprocessing
pros,
right now.
basically.
Yeah.
Yeah.
What?
Oh, I left the.
We're doing 8 things at
mask
once.
I mean, that's not only how this goes, but you're also doing 2 computers at once.
Yeah.
We are
I've done
We're
a lot
so
of
good at
Derby
this.
nights, and we've done computers at once, and they've all been over Zoom. So
just gotta know when to
this
mute
way,
yourself.
once we get to deep space objects where there's like 5-minute or 3-minute exposure times, then
can
we
do
can
something
have
else with
one
this
telescope be
one.
doing the long exposure while the other one takes pictures.
That's a pretty neat idea. I still don't know how you're doing transmitting that camera in that screen.
Because this one is also large.
It's also in Zoom. So both computers are in Zoom.
3 computers.
Oh,
Yep.
okay. Okay, then.
You got it?
Okay, yeah. I thought you were doing some
Sweet.
magic there. Yeah, it's just 2 computers.
I took a picture of Mars, but it has a lot of fraction because there's a gradient on it.
Sweet. Are we at Mars now?
Well, I'm gonna go take a better picture than the one with the mask on.
So back to what I was saying before we were talking about focusing. Sometimes we want to decrease the focus. Just spread the light on the detector up. Because sometimes objects are way too bright for us to do science. And so when it's super in focus, all the light is in a few pixels. And what that happens is our camera saturates. You probably have seen this if you try to take a picture of the sun. It looks like nothing, and you can't really tell any detail. By defocusing, we spread the light out over many pixels, and the object is no longer saturated, and we can do cool science with it. So sometimes that's important to do. Sweet. And now we're taking you to our closest, our most wonderful planet, Mars. Mars tonight is 2 astronomical units away from Earth. What that means is 1 astronomical unit is the distance from Earth to the sun, something like 90 million miles, which is a lot of freaking miles. So that means that Mars tonight is something like 180 million miles away.
Shouldn't be, because I took
Sweet.
a short exposure. is right in the middle.
There's like there's this livestock feature. Have you tried it?
Livestock?
And on the image on the left, you see a little tiny dot. That is actually the planet Mars. Am I correct? That is the planet Mars?
Yes.
That is the planet Mars we're seeing. We're going to work on making the image look a little bit cleaner using some built-in filters from the program that we're using to print out this image for you. Mars should appear red, but our detector, our image, our camera, it does not care about the color of light. All it knows is whether light came in or not. And the way that we do science is we have filters. We basically put in a red filter that only will let in red light or blue light or green light based on the filter we choose. But in the end, the image on our detector or on our program is still going to appear black and white.
Later, but that's
And if you have any questions, if you're live on YouTube, you can feel free to drop something in the chat. We're monitoring that window, and we'll be able to answer any questions you might have about what you're seeing, what you're not seeing, random questions about astronomy in general. We're happy to try to answer them.
Also, get ready to say goodbye to Jay and I's pleasant faces, because it is now dark enough that we need to turn the lights off so we can start to do some better astronomy.
Red light. So red lights are really good for astronomy. It's actually the same reason that you have red lights on the back of your car when you brake. They allow your eyes to adjust to light much more quickly. And so when you're driving along at night and you see a red light, your eyes register it more easily, and it's safer. And it doesn't make your eyes, your pupils, shrink up because it's so bright.
I can look at a star cluster. Let's see. There's the Beehive clusters up.
If you change the stretch, I don't know if we might be able to see the moons of Mars.
So I have gotten a moon of Mars before.
Ooh.
Because they have very short orbital periods, so they'll move. You take a picture half an hour later, and it's a different spot. But I'm guessing that it might be rough at the moment since it's still pretty light out. Maybe in like 10 minutes.
Sure. We might come back to Mars. We're right now.
We will come back to Mars.
Alex, where are you taking us?
I'm taking us to the Beehive Cluster.
Wicked.
As in baby beehive.
The Beehive Cluster, I think, is an open cluster of stars.
It is
right?
an open cluster. It would be great if it were a globular cluster.
So I don't know if you heard Alex, but he said it'd be great if it was a globular cluster, because globular clusters are infinitely more cool than open clusters. But open clusters, shots fired all the time. Open clusters are so much less interesting to look at, but they are the birth centers of young stars. And the reason they're open is that long, long ago, the big gas cloud collapsed into multiple stars. So one gas cloud doesn't give birth to just a single star. It always gives birth to multiple stars. And as those stars evolve and they're born, they slowly start to escape each other, and they shred away the gas that's around them. And what we see afterwards is an open cluster of stars. A globular cluster, which we won't see, are some of the oldest stars in the universe, and they actually orbit outside of the plane of our galaxy. If you've seen images of galaxies, they're pretty flat. You can see them at various inclinations from edge on all the way to face on. These globular clusters that I keep talking about that are super cool, they orbit outside the plane of our galaxy. Just for reference, we're inside the plane of our galaxy. We're sitting inside the pancake. So is the Beehive Cluster. Yeah. Alex, do you have something to show us?
Yes.
All right.
I'm particularly happy about it. So.
Do you want to narrate?
So yes, this is part of the Beehive Cluster. Beehive Cluster is a bit spread out for our telescopes. You're There are things you can do to make a telescope, quote unquote, zoom in and zoom out in terms of increase the magnification and decrease the field of view, or increase the field of view, which is what we'd like to do here, and decrease the magnification. But for these ones, we're mostly at the resolution that we're at. So I'm going to try and find you something more interesting than the Beehive Cluster. And so I'm going to keep sharing my screen, but I'm going to share the other half of my screen so I can introduce you to our cool software, Skyx. So this, you saw it behind me earlier, over my shoulder, while it was still light out. And now, what? Turn on my camera.
Yeah. All the magic's happening there. I don't want to see it.
Oh.
It's that window right there. There you go.
All right. So yes, we have the Beehive Cluster, which we just took a look at, and it was maybe slightly disappointing. Mars is, as you can see over here, and we'll come back to it in a little bit. When it's properly dark, we might be able to get a blur that is one of the Mars's moons, which is pretty exciting. But here we can see all the various things that we have to point at in the sky. Most of the exciting things, in my opinion, are going to lie not in the outside the plane of the Milky Way, but rather inside the plane of the Milky Way, just because there's a lot more stuff in the galaxy that we can see than is outside of the galaxy. However, there's still good stuff going on in these other spots, and we are able to take pictures of them. So let's see. I think we might be able to see the Sombrero Galaxy, so I'm going to look for that. And Jay can do the same thing with his telescope. So once we get going here, which we should be, the show is about to start for real now. We can bounce back and forth between the telescopes as we look for things. If you happen to know that something's up and you really want us to take a picture of it, feel free to drop it in the chat, and if it's available, we'll go take a look at it.
This one, Alex, what's that yellow circle around the...
Oh, that's a great question. So this yellow circle is the extent to which our telescopes can see in the sky. So if we have a target, we want to make sure it's inside the yellow circle. If I zoom out, this orange circle is, no, not that orange circle. Well, there's the sky that we can see from Boulder, but we can see more than just Polaris right now. But for our purposes, whoopsie, whoa, I'm going to make you all dizzy. I apologize. This yellow circle is the vision of our telescopes. And if you're wondering why it's lumpy, it's because there are things like trees and the edge of the roof that are in the way. I'm now pointing my telescope at M101, which is the Sombrero Galaxy, which is edge on. That means that it's going to look something like that, but it's going to look a little different than that because its name may give you a hint as to what it might actually look like, because it's the Sombrero Galaxy. As a deep space object, meaning not nearby, not a bright star, relatively dim, it takes us a little longer to collect enough light from the Sombrero Galaxy to get a picture of it. And we're fighting also the fact that there's still plenty of light in the sky right now. However, I think that it's late enough that we'll be able to get something here, but I am going to take a minute-long exposure. So with that, I will pass it over to Jay.
Hello again. So I've taken Artemis, our Eastern telescope, to another galaxy that's actually going to look a little bit similar to the Sombrero Galaxy, which Alex is taking us to. I'm taking us to something called the Cigar Galaxy, also known as M82. Or it could be M81. I'm trying to remember. It's M81. So actually, I think M81 is Bode's galaxy. So let me correct myself. We're going to look at a different galaxy at a lower inclination. So it's going to be much more face on than when we see the Sombrero Galaxy. And right now, unfortunately, I think it's still too bright. I can share the image that I'm getting of this galaxy that I'm trying.
Oh, the filters.
Let's see. There's a way to change the stretch. I'm gonna share screen. Boop, boop. Wicked. So this is the image I just took. It looks really bad, right? You see there's something happening here in the middle, but it's kind of bright. So here's what I'm going to do. I'm going to calibrate the image a little bit, if I can remember how to do that. Oh, God.
I'm gonna steal.
Yeah, I'm going to let Alex take over while I figure this out.
Okay, I have a picture of the Sombrero Galaxy. We had to fight to get this picture with, as you can see, still light behind me, but these telescopes are awesome. So you can see, if you see my mouse cursor, there's the bright spot in the center of the galaxy, and this light goes out to the side, and ignoring the dust bunnies, which I talked about earlier and are very prevalent now because we let a lot of light hit our camera, you can see this kind of darker ring, which is this dust encompassing the Sombrero Galaxy and blocking the luminous matter within it from shining directly on us, which gives it its very distinctive, fun sombrero look. I actually, for once, think I took too long of an exposure here, which luckily is an easier thing to correct for, because if I let you see what this looked like when I first opened it up, it looked completely bright. Now I can see on my screen there's a little bit of the structure there, but mostly all this light is coming from the sky still. And if you look in the bottom left-hand corner over here, that last number there is the number representing approximately the number of light particles hitting the camera. And the maximum amount it can receive before it just says, I'm full, is about 64,000. So, but the fact that we got 57,000 from just the dark patches means that I had too long of exposure in this case for this time of evening. So I'm going to try, and luckily, since I'm taking a shorter exposure, we'll see what happens if I take a 5-second exposure. That was a 60-second exposure. So this should let in 1/10 of the light. And hopefully that will let the Sombrero Galaxy dominate more compared to the sky. All right, as you can see, this time my photo is dark at its default instead of too light. But let's see if we can get the galaxy back with some other settings again. That's a little better. So I'm not entirely sure this is a better photo than the last one, but considering that we're still getting a similar amount of information about the galaxy in 1/10 of the time, it is certainly a more efficient photo of the Sombrero Galaxy. Now I'm going to pass things back to, I'm going to pass things back to Jay here. Yeah.
I'm back. All right. So I'm taking us to a different object entirely because the positioning of M81, Bode's galaxy, was weird. So I've taken us back to Mars, actually, because Mars is looking pretty dope right now. Here is this picture of Mars, this really bright spot that you see. And I want you to pay attention to something else right over here. If you can see my mouse, that is one of Mars's moons. So I'm taking a picture every second, and I think it's actually a little bit too bright. So I'm going to abort that. I'm going to leave it at this 1 frame, and I'm going to turn down the exposure time to instead half a second. Because Mars is so bright, we want to decrease the amount of light we're getting in. And I'm going to change the binning of the image. I'm going to start taking this one more time. Wicked. Yeah. So Mars is super saturated right now. We can't really make out all the details, but we can see right over here one of Mars's moons. And I just want to point out how amazing it is to be able to take a picture of Mars's moons. Mars has 2 moons, Deimos and Phobos. They're tiny. They are smaller than New York City. They are 12 and like 18 miles. There's like one of them is like 9 miles across. One of them is like 18 miles or so across. And we are seeing this 120 miles away. And we're imaging something that's like the size of New York City from that distance. It's amazing that we can see Mars, right? Mars and it's one of its 2 moons. I'm not sure which one it is right now. If there should be 2 moons that we should see tonight. One of them might just be too dim, alas. Yeah. So if you have questions about the red planet, where we have right now a helicopter, you might have seen. 1 second. Where is the zoom control window? Thank you. The Perseverance mission, you might recall.
Ingenuity helicopter on the Perseverance mission.
Yeah, and there's also a helicopter that NASA engineers were able to build that is literally that sort of had a successful several few runs just over the past 2 weeks. Should we show the video, you think? Or?
Yeah, go for it.
All right. I am going to share a different screen, one of a video of this very awesome run that they had showing the Mars helicopter. All right, here we go. Share screen. Wicked. So I'll narrate it to you. Here's the beautiful red planet during the daytime near Perseverance's mission. And there you see, right here, the new helicopter that's achieving flight on Mars. This is a video of its longest flight yet from a few days ago. And as you can see, it's very exciting here in the control room for Ingenuity. Yay. And here's a picture from a camera on the bottom of it showing it land. This is actually really exciting because as we continue future missions to Mars and possibly other planets and moons, having a helicopter or something that can fly across the surface is super crucial. It's important for getting around because right now, as it stands, our rovers are actually really bad. They're really slow. It takes them a long time to go a small distance across the sky, not across the sky, across the surface. With flight, we're going to greatly increase the speed and the ability for us to probe science across the surface of Mars. Yeah. Alex, do you have anything to show us?
My last picture was a failure, so I'm afraid not.
Okay.
But I will quickly go take a picture of something else.
Alex is working on taking a picture of something else. And so
No, I'll take a picture of a cluster again.
Okay, cool.
Those will not take long, and will allow you to.
Yeah. Once again, drop something in the chat if you have any questions. Talking about Mars tonight, we're talking about galaxies. If you have any other questions, we're gonna be more than happy to take them and try to answer them. Yeah. All right. So.
Oh, wow.
1 second. All right. I am going to try to take us to something called the Crab Nebula. It is the first Messier object imaged by Charles Messier, who is that whole catalog that you might have heard of before is named after Messier because he wrote a catalog of things that were not comets. Basically, Charles Messier was trying to find a bunch of comets, and he found a bunch of other quote unquote annoying things in the sky that look like comets to him.
Nebulous objects.
Nebulous objects is what he called them. Thanks, Alex. And so it turns out that these, yeah, I totally forgot your name there for a second. High pressure. Anyways, Charles Messier was trying to find comets. He found a bunch of annoying objects that weren't comets, and so he made a catalog to tell other observers, hey, if you find these things here, that's not a comet. That's just something else that we don't know about. And today, that catalog consists mostly of nearby beautiful galaxies and nebula here in our Milky Way galaxy, as well as several other local objects. Yeah. Alex, do you have anything for us?
I do.
All right, I'm passing it over to Alex now.
All right. Well, Jay is trying to get a picture of the Crab Nebula, and best of luck to him, because I just struck out trying to do that.
Oh, you tried to find crab?
I tried the crab, and it did not turn out well. But
Oh.
you have about one shot at it, because it's about to go over the horizon. So good luck.
It is? Okay.
This is the Heart Cluster, which is another star cluster that we talked about. So the reason why we find stars in clusters is that they form in clusters. So there'll be a lot of hot gas, and that gas is drawn to itself, essentially, and to other hot gas in the area through gravity. And as that gas collapses, the pockets of it, the little bits of it that are more dense, attract more gas to that part that's more dense, and more parts form, and more gas comes in until there's enough gas that, boom, a star ignites, and you have stellar fusion, and you have a new star.
Saying a star is born.
Exactly, a star is born. And that said, that uses a very small amount of the hot gas that was in the area. And when I say the area, I mean an area significantly larger than the solar system. But so a bunch of stars will tend to form in a similar area. And you get clusters of stars, which are very cool. I'm going to go take a picture of one more star cluster, just because since stars are very bright compared to some of the other things we like to take pictures of, it does not take long to take a picture of a star. As you can see, I've set my exposure time here to 1 second. It's actually double that because I'm also taking dark frames at the same time to help calibrate the telescope. Oh, let's see. Ah! The red light, the color out of space is here. Oh, I might have started the picture while my telescope was still slowing. It looks like there's movement in the image. Oops, my bad. Let's do this again. There should be lots of stars here. Why is this not getting the image I want from this? Well, that is the Calabash Nebula, which is another stellar cluster. I'm going to go see if there are any other galaxies hiding out there for us. Or maybe the Jellyfish Nebula. Nah. Do you have anything, Jay?
Working on it.
Oh, this random patch of nebulous sky. Okay, I've taken pictures here before and they've turned out well. So I'm going to come back. I'm going to go for another long exposure, although that hasn't worked out well for me this evening. Okay, so what I'm doing here is Skyx is nice for us. Oh, let me share my other screen. And that it has some images of some of the things that we're trying to take pictures of already. Wrong screen. And so I can see here that there's some nebulous object in the sky here. And how do I know that this is nebula? Well, there's a couple different types of nebulas, but this is one that the one here is probably a star forming region, similar to what I talked about where we had the star clusters before. But this is what happens before there's a big star cluster there. So there's still a bunch of that hot gas there. That gas is glowing. And what's more, that gas is hydrogen. And so by putting a different filter in front of the telescope, I can block out most of the light coming into the telescope, but still pick up a fair bit of the light coming out of the hydrogen because it releases light at a very specific energy. And so if we only let light from that energy level in, then we can hopefully get a picture of some of the structures of this gas cloud here. Pictures of gas clouds are some of my favorite things, but they're pretty dim, A, and B, since we're blocking out a very large percentage of the light coming into the telescope, we have to take a long exposure here. So I'm going to go ahead and take a 4-minute exposure. And hopefully this works for me. If not, then it's 4 minutes of the time. Not completely down the drain, but it's a high risk, high reward endeavor to take a long exposure picture like this. Now, when you take a long exposure like this, the Earth rotates during your exposure. So the Earth will have spun 4 minutes during the time of my exposure, and as such, the object is moving on the sky. But luckily, with our fancy telescope software, it can track the rotation of the Earth and the objects in the sky, and so it will continue to point at the same spot in the sky during the entirety of my exposure. Jade, you got something?
I do have something.
All right. Why don't you take things back?
I'm gonna put the light on my face so I don't appear. Sweet. All right, so I have taken us back to Bode's Galaxy. This is M81. Let me share my screen. Here you go. The image is about to change in a few seconds. This is an H-alpha, hydrogen alpha image. This is an image of just the hydrogen in this galaxy. As you can see, it looks like nothing. There's just like a little blob there, and there's some extended something. You might be able to zoom in and say, hey, convince yourself there's something there. But, ooh. I just took a new image, and you're probably wondering, Jay, it looks completely saturated. Don't worry. The program can help us out here. Drum roll. Okay, here we go. We're cooking. I'm gonna cooking with gas. That's right. So the object now appears much brighter, as you might have noticed. So I'm going to turn down the stretch a little bit. And voila. Not as impressive as I had hoped, but there's going to be a disk of galaxy stars and gas and dust in this galaxy. That's what this extended emission we're seeing is. There's actually a spiral arm right where my mouse is pointed. And I'm going to take this opportunity to shout out at Alex. Alex, do you want to go to M82, which is the Cigar Galaxy? I think we might be able to get a better look at that.
All right, I will when I'm done taking a picture of this nebula.
Oh, wicked. Sweet. So Bode's Galaxy has a lot of dark dust lanes. So I'm actually going to hop over and stop sharing this, and I'm going to show you something on Google from Hubble. Let's see, Bode's Galaxy. So one natural question that we often get is, Jay, how far away is Bode's Galaxy? Bode's Galaxy is an enormous distance. So if you imagine that I told you that Mars tonight is at, let me share my screen again. Drum roll, here we go. Here is M81. So as I told you before, M81 is a spiral galaxy. Look at that beautiful gas and dust. It's a beautiful color. M81 is an enormous distance. It's 11 million light years. So it took light from M81, light that we're looking at right now from our SBO telescope, not this image, but on the other screen that I had shown you. It took that light 11 million years to reach us here. 11 million years ago, I think we were still crawling out of trees and such as human beings. So I can't even fathom how long ago this image, the light that we took this image is from. M81 actually has a companion galaxy called the Cigar Galaxy that we'll show you in a few minutes. It's part of a group of galaxies, actually. There's another galaxy called the Garland Galaxy nearby as well. And what happens when galaxies are near each other is that their gravity is so huge that it has an effect on its companion galaxy. So galaxies other nearby to it start to experience lots of effects. And I'm going to go into those a little bit more in a few minutes when we show you the Cigar Galaxy, because that's where we see that effect most pronounced. The gravitational interaction of galaxies and understanding them actually has a lot of importance to us here on Earth, because you might have heard that our neighbor galaxy, the most closest galaxy to us, which is I think only 8 million light years away, or even closer than that, 2 million light years, excuse me, the Andromeda Galaxy, which we cannot see right now, but at other times of the year we can see it, even with the naked eye if you're in a really nice dark spot. One day, in something like 500 billion years, maybe that's an overestimate.
I think that's an overestimate.
100 billion years?
No, I think it's like another
1 billion?
20 billion.
20 billion years.
Billion.
20 to...
About twice the age of the universe as it is currently.
Okay. So
14 billion years.
The universe right now is 14 billion years. Alex says in about another 14 billion years or so, our own galaxy is going to collide with the Andromeda Galaxy. And you're probably wondering, oh no, Jay, are all the stars going to crash into each other?
Me. Only 4.5 billion years.
Oh, only 4.5 billion years. So
it's practically tomorrow.
Practically tomorrow in astronomy timescales. That's actually very soon. But
about the same time that the sun is going to start doing very interesting things.
Yes. So if we're around in another 4 billion years, and we have avoided several calamities that will arise from our sun evolving, our galaxy will collide with the Andromeda Galaxy. And the amazing thing is, even though there are hundreds upon billions of stars in our own galaxy, and hundreds upon billions of more stars in the Andromeda Galaxy, they're so far spread apart that we're not actually expecting stars to collide. What will collide is all the diffuse gas, like you see here. Instead of all these specks, imagine there's continuous bright spots. All that gas is going to collide. Now, I'll tell you a little bit more about what happens then a little bit later. Alex, back to you.
Yeah. So I have a picture of a gaseous nebula for you. Whoops, wrong screen. This would look great if we had color and not just one wavelength on our, or not just imagery on our lights here. We have to take this same picture with a bunch of different filters and overlay them to get color out of it. But you can see, besides the bright stars, that there's something else here. And this is, for once, not the sky. It's now dark enough that this is the hot gas in this area. And you can see that there are darker patches where there are less of it, and there are lighter patches where there are more of it. And I took this with the same filter that Jay used to take a picture of the last galaxy, which is the H alpha filter. And once again, that is meaning that we are seeing largely hydrogen. Hydrogen gas is what is here and releasing all this light between these stars. So this is the diffuse gas that will be expected to collide with things when Andromeda and the Milky Way meet up in a couple billion years. And this is the sort of thing that if you're sitting here on Earth, well, actually, it might look kind of interesting because there's going to be a lot more stuff close by in the sky. If you think that the band of the Milky Way is thick, if you added an extra band that was Andromeda all the way across the sky with all the various nebulae and star clusters that are in Andromeda, then you'd have a lot of stuff up there to look at. So that it would still look cool from Earth. But if you managed to fly a camera way out back from the Milky Way so it could look at both the Milky Way and Andromeda, it would appear to be this insane collision on that scale. Stuff would go flying off of the galaxies due to the extreme rotational forces. They would zoom past each other, and then in another billion years or so come back and move past each other again. And each time, bits would be pulled off of each one towards the other. It'd be very exciting stuff. But as Jay mentioned, on the local level, you'd probably just be sitting on the planet around your star, flying through space. But this is, again, a picture of the diffuse gas, the hot diffuse gas that is going to be driving much of the action in that collision. This is slightly different shading of the picture, pretty similar to the other one I had there. You can kind of play with the settings, but this is about as good as it gets for this particular cloud of gas. I can also make it so only bright stuff shows up, in which case the gas is all gone now, but there's still a lot of stars in the area, you'll notice, because, as we mentioned before, with hot gas comes new stars. All right, Jay, what you got? Take us home.
All right. Back to me. All right, I've got a pretty dope, this is one of my favorite galaxies to look at. Here is an image of the Cigar Galaxy. As you can see, we're seeing it fairly edge on. That's why it doesn't appear flat like a pancake. Instead, we're seeing it this way. And it's sort of a little bit difficult to tell, but you see actually features here, diffuse and really bright gas and dust that make up this beautiful spiral galaxy. Here's something really cool that's happening. This is actually very close. In fact, the telescope barely moved to go from Bode's galaxy, the last galaxy I showed you, to the Cigar Galaxy here. And here's why the Cigar Galaxy is really interesting. Because it's so close to Bode's galaxy, the gravity from Bode's galaxy has perturbed the gas, all that gas that eventually formed stars in this galaxy right here, in the Cigar Galaxy. What that ends up doing is it triggers a lot of stars to form because the gas has moved just a little bit, crashes into each other, and it collapses and forms new stars. And because of that, we call it a starburst galaxy. It's undergoing a lot of star formation. 10 times more stars are born right now in the Cigar Galaxy than are born here in the Milky Way. That actually produces another effect. Because this star formation has been happening for so long, for a few million years now, some of the biggest and brightest stars will have already started to die in the Cigar Galaxy. And so we expect to see more supernova coming from the Cigar Galaxy than we see in ordinary galaxies like the Milky Way or Andromeda that aren't undergoing this effect. And in fact, we've already found 2 supernova here from the Cigar Galaxy. And we expect to see more, which is actually very unusual. You expect to see supernova less frequent than that because of, again, this starburst activity that's being generated by the nearby gravity of its companion galaxy. Yeah, this is I'm really glad that we took this picture.
That's a great picture.
And if we're lucky, let me see. Alex, I think we're right around 9 o'clock.
We are right around 9 o'clock.
If you have any last questions, feel free to ask us. Do you have anything to show us, Alex?
I still have 1 minute left on this exposure, so we'll go 1 minute over.
Sweet.
While you are putting any final questions you have in the chat, I'm going to be attempting to take a picture of the antenna galaxies, which are 2 galaxies that are in the process of colliding with each other, just like the Milky Way and Andromeda will in about 4 to 5 billion years.
Nice.
Just because 2 things are next to each other in the sky does not mean that they are actually close by physically, because one could be a lot closer to us than the other. I don't know what my
So I'm attempting to take a picture of the antenna galaxies. They actually are colliding. Just because things are close doesn't mean that they are actually close to each other in the sky. One could be much farther than the other. If I hold one hand here next to the camera and one hand close to my face, doesn't mean that this hand close to my face is close to this hand, even though they look like they're right next to each other from the perspective of the camera. All right, let's see if this turned out at all. Oh, maybe barely. This was a short exposure for what I would normally do for something like this. Maybe here. No. You can almost get something.
Try the heuristic filter.
Which one's that?
In the bottom corner. Method custom, try heuristic. Didn't work.
That's all right. Oh.
You can zoom in, it'll look nice.
All right, well, we can see barely something here. So to finish things off, the Cigar Galaxy would have been a better way to finish things off, but this was a worthy try. So this is our 1 minute exposure. And again, for things that are this far away in this dim, you typically want a larger exposure, longer exposure time. You can kind of see the shape here. These are two colliding galaxies. You can also look up the antenna galaxies if you want to see a picture that was taken with a little bit more time and probably with a better telescope. But they are colliding, which is cool because big scale collisions do happen in the universe, and we can see them when they happen. I don't have any questions in the chat, so thank you for joining us, and have a great evening.
Bye, all. Thank you for joining us.
I'm Alex. This is Jay. And come back in the fall, and we'll be able to do stuff in person.